This video shows you how to relate decimal and fraction multiplication. In this lesson, it's going to be important that you remember what we learned when we were using your place value chart. If you don't have a place value chart, it might be good to look one up online. There are many of them out there. Remembering that base 10, where 1 times 10 is 10, times 10 is 100, times 10 is 1,000, and it works the opposite way if you divide. Okay, so let's look at a problem. If we have 1/10 times 4, okay, we can look at it as a fraction problem that we've done before, where you have 1/10 times 4, knowing that 4 is the same as 4 over 1, okay, and we'll multiply across where we have 4 times 1, which is 4, and 10 times 1, which is 10. In this case, we're not simplifying because we know that 4/10 can be turned into a decimal, where we have 0 and 4/10. Whereas if we simplify it to 2/5, we're not going to easily be able to turn that into a decimal. Okay, the way that I turned it into a decimal here with 4/10 is I took my 4 and divided it by 10. 10 goes into 4 evenly 0 times, but I can bring down a 0. 10 goes into 40, or 40/10, 4 times. Remember that decimal's already there. Okay. When we use our place value chart, it's also important to remember that we start with 4 ones, but we're multiplying it by tenths. So really what we're doing is we have our decimal here, but we're moving the number one space to the right because it's getting smaller, and it's only by tenths. So now we have 0 ones and 4/10. Okay, I only moved it one place because I only need one number in the decimal there. Okay, let's look at another problem. Okay, 1/10 times 1/10. And the way that you can use an area model to solve this is looking at your graph paper, which is split into tenths in each direction. And let's look at 1/10 horizontally. I would have this section here along the bottom. If I were to look at it vertically, I would have this section here. Okay, but only in this bottom left square do I have both the blue and the green. So I would have 1 out of a total of 100 squares. Okay, another way I can look at this is 1/10 as a fraction times 1/10. And 1 times 1 is 1, 10 times 10 is 100. So using the area model here is just another way to look at it. And once again, the way that I got 1/100th is there are 100 squares total. And when I look at my 1/10 and 1/10, there's only one square that has both sections. Using that information, try the next problem on your own. We have 2/10 times 1/10. Okay, I solved this two ways. I did multiplication of the fractions, where I did 2/10 times 1/10. 2 times 1 is 2, 10 times 10 is 100. I also drew the area model out here, where I highlighted 2 sections here in blue and 1/10 in green. And when I look at that, I have 2 sections here where both green and blue meet each other. And once again, there are 100 sections total, and I'm only needing 2 of them. Look at another problem. 5/10 times 1/100th. Try that on your own. When I solved this, I did it as a fraction first, 5/10 times 1/100th, to get 5/1000ths. And then I used my place value chart here. I have no ones, I have no tenths, I have no hundredths, but looking at this, I do have 5,000ths, so I have 0.005. Okay, for me, it's easier to solve it as a fraction first and then convert it into a decimal using the place value chart. I can use the same technique when I multiply using a number that has a whole number and a decimal. So try this one on your own. 1.5, or 1 5/10, times 1/100th. We could solve this two different ways. The first way you could do it is break it down, where you have 1 times 100th, and I did 10 over 10 because I'm working in tenths, plus 5 tenths times 100th, and then multiply and add them across, where you get 15 1,000ths. But that's a little bit more work than we need to do. I would turn it into an improper fraction, where you have 15 tenths times 1/100th, and then you can just multiply straight across, where you get 15 1,000ths. And then plug that into your place value chart. We have 0 1s, 0 10s. We have 100th from our 15 here, and we have 5,000ths again from our 15. So to write it as a decimal, it would be 0.015. Okay. At this point, I'd like you to compile what we've talked about and compare the products of 7 times 2 tenths, 7 tenths times 2 tenths, and 7 hundredths times 2 tenths. The suggestion that I would make is try using a place value chart to see if that helps. When you solve this, you'll realize that you have very similar numbers. Here we have 7, which is actually 7 over 1, times 2 tenths, then 7 over 10, 7 tenths times 2 tenths, and 7 over 100 times 2 tenths. Okay, the 2 tenths does not change at all. The only thing that really changes is adding a 0 at each of these. And when we multiply that across, we see that translates into moving the numbers 1 decimal place to the right for each one. So you go from 1 4/10ths to 14 hundredths to 14 thousandths. Okay, we're just moving in another 0.